Hello, everyone. Welcome to today's LinkedIn Live event, where we'll be talking about hydrogen locomotives and the path to zero emissions rail. I'm Larry Jordan, the CEO of Wi-Tronix, and with me today is Kyle Mulligan, the AVP of Operations Technology with Canadian Pacific. So as we get started, maybe what we can do here is, Kyle, give me a quick rundown of your background, and we'll get started with that.
Okay, thank you, Larry. I appreciate being here today. So a little bit about me. I have a PhD in aerospace engineering with degrees in computer engineering and electrical. After graduate studies, I joined Bombardier Aerospace and worked in the aviation sector before becoming a railroader here at Canadian Pacific. I've been with Canadian Pacific for 8 years, taking on progressive roles up until the Assistant Vice President of Operations Technology, where 50% of my time is focused on implementing technologies with my team to increase safety and reliability of the railroad, and the other 50% is working on zero emission propulsion technologies. The last thing I'll say is that I am a qualified locomotive engineer, conductor, railcar mechanic, and welder here. So something we encourage here at CP is to have our managers not only work in the office, but have a practical side so that when we do take on initiatives like the one we're going to talk about today, we can take it on from a railroad perspective.
Yeah, that's a great point. Here at Wi-Tronix, we call it Gemba. I think it comes from some of the techniques they've used in quality management that came out of Japan, and so, yeah, Gemba is so very important. So today we're going to be talking about hydrogen locomotives. So perhaps you could start off and describe to the audience, what is a hydrogen locomotive? How is that different from a diesel electric locomotive, and kind of start at that point?
Yeah, so hydrogen locomotives, if I go to basically a diesel locomotive utilizes a diesel engine and alternator to generate power, which is flowed into the already existing electric traction motors. And so essentially a diesel electric locomotive is already a hybrid platform, uses fossil fuels to generate the energy, but that energy flows into electric traction motors. So when we approach the hydrogen locomotive, what we're looking to do is remove the diesel engine, alternator, cooling system, and other components, and replace them with hydrogen fuel cells, lithium-ion batteries, an upgraded cooling system, power electronics, and then onboard hydrogen storage, which is in the form of hydrogen cylinders. Fuel cells in themselves are interesting in that they electrochemically react hydrogen with oxygen. So there's no combustion in a fuel cell. It's an electrochemical reaction, and it generates sort of two things. One is water vapor as the exhaust, and then the other piece is electricity, which can be flown into those already existing electric traction motors. And so we've taken the concept of what we call zero emission components, such as hydrogen fuel cells and batteries, and integrated them on board the platform into the existing locomotive.
So with a diesel engine, we've got combustion, as you noted. There's no combustion in a fuel cell. There's a lot of moving parts. Progress rail engine, 710 cubic inches per cylinder, a lot of mass and motion. Are there a lot of moving parts to a fuel cell? Is it loud? Would we hear it go by?
So no, there aren't a lot of moving parts to a fuel cell. There is each fuel cell has a compressor, which does make some noise. But ultimately, in comparison to a diesel electric locomotive, a hydrogen fuel cell locomotive can pass by you pretty much imperceptibly. There are, of course, the conventional components that we need within our industry, such as the air compressor used for the air brake system. So you would hear that cycle on and off. and then to, cooling of the fuel cells, and because of that electrochemical reaction is very important. So there are onboard cooling pumps, and there are rad fans that cycle on and off. But overall, significant reduction in noise versus a conventional diesel electric locomotive. And then, to your point, you don't have crankshafts, you don't have connecting rods, pistons, and you don't have associated onboard lubrication to support that process as well. And so you have these basically virtually almost pure electrical devices on board now versus a conventional locomotive.
Right. So fuel cells, we don't really see them in our normal lives very much. Is this fuel cell technology? Is it a kind of bleeding edge technology, or have fuel cells been around for a while?
Well, fuel cells date back several decades to the NASA's Apollo program. So they were originally used on board. I think they were developed by General Electric for NASA to basically take hydrogen, electrochemically react it to produce water for the potable water for the astronauts. And they've progressively made their way over several decades. One of the key players is Ballard Power into the transportation sector. They were originally targeted for automobiles, but have progressively seen sort of a renaissance in the heavy equipment industry, specifically mining, railroading, and marine. So they are not new. Even in the automotive sector, you hear a lot about electric cars that leverage batteries, but there are also fuel cell electric vehicles now starting to gain momentum, certainly on the west coast of the United States and Canada. So to answer your question, not new, but it's taken several decades for them to be adopted, refined, and really be able to produce the energy densities required to even make them feasible for transportation.
Right. So you mentioned fuel cells being used in cars and Ballard as a fuel cell manufacturer supplier that's been around for a while. Is Ballard also applying fuel cell technology to other heavy vehicles, whether it be ferries or other types of big, very large equipment that would be comparable to a locomotive in the train and rail industry?
Yeah, Ballard, they have a wide spectrum of product offerings for automobile, marine, heavy equipment industry, and I'd say a little bit less so on the rail side. So interestingly enough, when we embarked on this project to convert the locomotive, when we went to fuel cell providers initially, most of what we had access to were fuel cells designed for the automotive market. So probably consisting about half of the power output per fuel cell that we currently use in our current design. And interestingly, the marine industry came up, and Ballard had mentioned, we've developed these fuel cells. We're in the process of developing these fuel cells for ferries in Europe, and we think this type of fuel cell would be good for your application. And so we kind of used that as a basis and then transformed it into a rail application. And of course, that process is ongoing as we continue to test. But to answer your question, yeah, I'd say one of the key markets that we really caught on to that was most aligned and applicable that Ballard was offering was the marine industry.
Right. So let's kind of fast forward a little bit. Now CP has a hydrogen locomotive program. Why don't you describe to the audience kind of what does that mean, and what technology have you assembled for that program?
Yeah, so that's a wide spectrum question, but basically what it means is we currently have either built or in the process of building 3 hydrogen electric hybrid locomotives. The first locomotive that we started with was what we call a DC traction line haul locomotive. So it's, for all intents and purposes, it was an SD40 platform. And then we received funding thanks to Emissions Reduction Alberta to expand that program to 2 additional locomotives, 1 4-axle DC switch locomotive and 1 6-axle AC traction locomotive. And so why did we do that? Essentially, we did that because those are the 3 main locomotive types that exist within the North American freight rail industry. And so if we could demonstrate that we could remove the diesel engine alternator and sort of diesel related components, replace them with the zero emission components, then we could demonstrate to the industry that this technology is feasible and sort of understand how it can be adopted further. So we have successfully completed 2 of the 3 locomotives. They are in various stages of testing. The first one has completed 5 successful mainline tests. There's actually one tomorrow. And the second locomotive has now entered into yard testing. And so the goal for us with those first 2 units is then now to transition them into actual in-service, out of testing to in-service, which is expected to happen later this year. And then the third locomotive, the AC traction locomotive, is actually being built now, and it will have its first movement before the end of this year. So that's sort of what it means in terms of what we're doing. What it means to the company, what it means to our employees is a whole other space. This is an exciting time to be part of the rail industry. It's an exciting time to be looking at alternative traction mechanisms. It's also an exciting time to attract youth or others from other disciplines into the rail industry, because we are truly doing something innovative and transformational. And so not only does the program bring meaning to decarbonization, but it also brings meaning to the culture and workforce of the company.
Right. So CP is a rail operator, not an OEM of locomotives. So why tell me a little bit about the origin story of the program, and how do we kind of get to this point where CP is building locomotives? I guess for me personally, I saw a little bit of this last summer when I traveled on some CP rail and experienced the hotel at Banff Springs and Lake Louise, and kind of seen how railroads in the past have maybe ventured out of pure operating because it's important to their core mission. Maybe explain a little bit on CP and why the hydrogen program at CP.
Yeah, so I think CP, among other Class 1 railways, have made concerted efforts over the years to increase our fuel efficiency. And, we've done that through energy management systems. The other, many railroads have explored alternative fuels and continue to explore that. However, we've reached a point where, in order to decarbonize, we need to think differently. We need to sort of rethink what we're doing. And so there are various stakeholders within the industry, such as the investment community, which many investors are from countries and continents outside of North America, such as Europe, who have, made clear that decarbonization should be the goal of many corporations within the world. And so, it's important that we align ourselves with those expectations. But in addition to that, governments have also set very aggressive objectives, and ultimately we want to contribute to that. And then finally, I sort of alluded to, just in terms of talent acquisition and the sort of beliefs of youth and up and coming, technical staff and other types of employees who will be contributing to the railroads of the future. And so we really, wanted to align with that. Our leader, Mr. Creel, wanted to align with that. And so we were challenged as technical staff to understand what we could do. And so we proposed that investigating, it was of our point of view that the only way to truly decarbonize is to use hydrogen. And so starting off with that sort of train of thought, and then ultimately to where we are today and chipping away at that roadmap. Why are we doing it ourselves? Well, I think we're positioned as operators and as individuals who operate trains regularly, who also have the technical expertise, understanding how locomotives are modernized, and it's much more rare that you would purchase a net new locomotive. We felt we were in a good position to be able to take on a project like this and to demonstrate the concept.
Yeah. So both, so there's on the automotive side, a path to zero emissions. As you noted, there are hydrogen paths, but primarily it's been battery electric, and we've seen battery electric offerings from both Progress Rail and Wabtec. So tell me a little bit why hydrogen hybrid fuel cells as opposed to a battery electric freight locomotive.
So I think, well, in terms of specific to our industry, the way that we operate is quite unique. In terms of if you're operating in a terminal, as an example, one of the things that we have sort of mastered over the years is how do we fuel our locomotives and how do we do that in the most efficient way. So most terminals are equipped with fixed point fueling infrastructure, typically located near mechanical shops, because during inspections, that's a very convenient time to fuel locomotives. But when you're operating on a completely different end of the terminal, to bring locomotives back to a physical fixed point fueling location is often not practical. And so we have sort of moved to direct to locomotive fueling directly from the trucks. And so, a crew goes on a lunch break or there's a shift change, there are opportunities within your terminal to optimize those fueling events. And I'd say as Class 1 railroads, we've become quite good at that. If you think about battery technology, you can only really install fixed point fueling infrastructure. And so you're taking these locomotives to a fixed location to recharge them. And although you could have multiple fixed locations, you're running up against the time it takes to actually recharge these locomotives. And so to operate the same way that you do today, you essentially have to have a locomotive on standby, and you have to have the locomotive that you're recharging. So one is always charged, and so you're cycling locomotives in and out of the operation. Well, that essentially results in duplicating your terminal assets. It results in more maintenance, and the charging infrastructure to support, even if you take a 2.7 megawatt hour locomotive or a 14.5 megawatt hour locomotive, you're going to need to build a dedicated substation for that terminal. And not every terminal is located in a major urban area or in an area that has utility infrastructure that can support that easily. So unlike hydrogen, where hydrogen is transported today in gaseous trailers, liquefied tankers, there's fixed point electrolyzers that you can build. There are mobile refuelers that can be used. And so the flexibility of hydrogen is already there today. And then the last thing I'll say is just if you compare fuel cells to batteries, fuel cells have about 5 times the energy density of batteries for the same footprint, and they weigh a lot less. So if you want to continue to use four-axle, four-axle locomotives without going to a 6 or 8-axle design, which really, if you look at the current terminal infrastructure that exists, yards are four-axle switchers, let's say, do very well in yards based on the infrastructure that we've installed. And so if you were to build a locomotive completely with batteries, you're going to weigh out. And so you're going to have to, that might work well in a mining environment where the infrastructure is already quite beefy because of how they move and what they move. But in a class 1 terminal environment, that might not necessarily apply. And so you have to take into account your current infrastructure and the capital cost to improve that infrastructure if you're going to go with a battery only design.
Right.
So yeah, long-winded answer there, but there's a lot to it in terms of how you're picking and selecting one technology versus the other. And the last thing I'll say is just a fuel cell electric locomotive still uses batteries. So you still have that battery requirement on board, but you're leveraging the fuel cell to for the benefits I just illustrated, but also to fill in that horsepower gap that you're missing from just having batteries alone.
Right. So if you had a battery electric locomotive, let's say that the kind of the highest end out there is 14 megawatt hours. So would you have like a tenth of the amount of energy storage that you would use, something like that, or would it be even less?
So yeah, in terms of if you were operating a 14 megawatt hour locomotive, how would it compare to the energy density of a fuel cell electric locomotive?
I think it's more so you noted that you still have batteries just as part of the fuel cell hybrid. Is it compared to the amount of batteries you would have in a pure battery electric, is it like 1/10 the number of batteries, or yeah, just maybe give a little bit of a yardstick there.
It's about a tenth of the requirement. Yeah, in the case of 14 megawatt hours, it'd be a 14th.
Okay. So you still get the experience and learn kind of the battery technology, and then add on the fuel cell and hydrogen handling kind of all in one program. Is that correct?
That's absolutely correct. Yes.
Right. Okay. So as a railroad that's working on a program, you don't have hundreds of engineers and a ton of experience. You must work with a number of partners. So tell me a little bit about, you mentioned Ballard earlier. Tell me a little bit about the partners that you're working on and how you're leveraging those partners to help the program come to fruition and be successful.
Yeah, it's a great question. Yeah, so I would say the internal team that we leverage is quite lean, but at the same time, it kind of has to be. And I always use this analogy. I say, you can only fit about 6 people in the cab of a locomotive when you're troubleshooting. So keeping the team lean, and the team that we have, the subject matter expertise of the individuals, they truly are masters of their domain. So it's definitely critical. Now, as we expand further, we'll require more employees to support these locomotives, especially as they go out on the property. But in terms of the development and build, it is quite lean. Having said that, as you said, we have a number of suppliers that we work with, and these suppliers have dedicated technical teams that are working on our project. And I'd mentioned Ballard Power Systems as one of them. We also work with Bilton Welding and Manufacturing out of Innisfail, Alberta, which was recently in the media. And we work with a number of other suppliers in Europe and the United States as well. So each of these suppliers, as I said, they have a number of experts that support us, that help us troubleshoot. I always say you can buy the individual zero emission components, but there isn't a manual on how to integrate all of these on board a locomotive. And so it's truly been a learning experience between us and our suppliers, and we've worked with them hand in hand in order to be able to accomplish these locomotives.
Right. And in fact, we met probably about a year ago, and Wi-Tronix is also providing some technology for the program. Maybe describe a little bit how does IoT technology help with a hydrogen locomotive program?
Yeah, absolutely. So, you know, the onboard Wi-Tronix has been absolutely key to our ability to offload data off of the platforms. And so when we think about IoT and the access to the information, that is, you know, integrating the components is one thing, wiring them up, getting them to turn on and off. But now you have to take those components and you have to build a control system that will allow the operator essentially to put power to the traction motors. And so within that operating system, because we're leveraging hydrogen and we only have dedicated fueling sources of hydrogen right now, we leverage the IoT platform that you offer to optimize those components in terms of when they turn on, when they turn off. The other item that it supports us with is really around energy management. So when do we have to turn these components on? How do we know we have to turn those components on versus where the asset currently is and where it's going? And so, you know, having partnerships like that are supporting us from a capacity standpoint as well, so that we can continue to improve the technology, make it more reliable, but also optimize its use so that we can demonstrate that this is actually practically something that will work for our industry.
Right. Well, thanks, Kyle. You talked about the team that's you know, a lean team and operational experience and moving quickly. But if we always look back, and when we apply agile principles, we look back at kind of lessons learned. So if you had kind of a do-over on the program, yeah, what's kind of a big takeaway, a do-over that, man, I wish I could have made that decision differently?
Well, I'd say certainly I wouldn't do everything the same. You know, we built the first platform. When you're building the first of anything, there are always a number of lessons learned. I think really what we tried to do was build this in a way that you could retrofit an existing platform almost seamlessly, reutilizing as much as you possibly can. And you know, the first unit, once it was completed, it pushed that concept, but it didn't push it far enough. And there were some decisions along the way. I mean, keep in mind we had to build the first one during a global pandemic, and so there's certain decisions and trade-offs that you make in order to make that successful. And you know, as you test the locomotive, you learn a lot. And so I think, you know, taking a bit more time to plan the first one probably could have been useful. I hesitate though when I say that, because at the same time, when you're developing a project of this magnitude, you know, ultimately you have to get a result at the end. You can
Right.
plan as much as you can, but you don't know what you don't know. So I think reminding myself that, you know, the first one's a prototype, and you know, you can already see a marked improvement between the first one and the second one. You know, when I think back about it, since we started really in October of 2020, you know, being qualified as a locomotive engineer and others on the team that are qualified, it was absolutely essential, because the amount of preparation it takes to even move the locomotive, test it on the main line. Obviously, we have a lot of operating employees that are very supportive of the program, but having that organizational sort of champion and having that network to be able to test these things and the ability to go out and test it yourself, I think is absolutely paramount to success of of the overall project. And so I think that's part of how we can move as quickly as we can move as well. We're still doing all the right things. We're part of consortiums about standardization. We do a number of risk assessments and HAZOP studies with every step of the way that as we execute the program. We are connected with Transport Canada and the Federal Railroad Administration on every step of the way, and we're very transparent about what we do. So we're not just building this thing in our backyard. We're building this thing properly by professional engineers. But the fact that we're also practical and we have field experience very much facilitates the build.
Right. So you mentioned they've got your next test is actually coming up tomorrow. So tell me a little bit about where you see the testing program and what does that look like? You've got some dummy loads you're pulling around, or are you really pulling freight?
Oh, no, we're pulling freight. So we are now at a point in the program where the locomotive is put into freight trains that we run for existing customers on existing subdivisions. And when I mean freight trains, I mean 20,000 tons. I don't mean 5,000 tons. So the locomotive, the first one, which is our DC line haul locomotive, has performed very well. What do we expect to get out of the testing? We're sort of looking at range across different temperatures. Obviously, testing in Canada, we can go anywhere from -20 to, or I guess in Canada, you can go from -40 to +40. And so we're really trying to understand how the locomotive behaves in cold weather, warm weather, and through various weather conditions, and how that affects our range. We're also trying to fine tune our auxiliary loads so that we're not dispensing power unnecessarily. And we're testing things like, how does the locomotive perform in consist with a diesel locomotive? So when you go and transition the industry, you're not going to just say, I'm going to transition all my diesel locomotives in one day. That's going to be a progressive transition. And so if you're MU'd or DP'd to a diesel locomotive, are there any differences? And I'd say the last thing is just getting hours on the unit. I think you told me this, Larry, as you increase the amount of hours, you can do all the testing you want in the yard or in a loop track, but as the hours go up, you learn and things fail and they don't do exactly what you expected them to do.
Right. So with that, I think we're going to kind of shift to the next section. We'll talk a little bit about the myths, hydrogen, and we sort of see this and when we're in school in elementary school, kind of the Hindenburg and hydrogen, and it's got a kind of a bad rap that's over 100 or almost 100 years old. I guess maybe 80 years old. So tell me, let's talk a little bit about the myths. First off, when you look at hydrogen, what are the safety concerns about it? You talked a little bit about safety analysis and hazard analysis you've done earlier. Talk to the audience a little bit about hydrogen and how it's stored and handled safely.
Yeah, absolutely. So you mentioned the Hindenburg, so I'll remind everybody, that was in 1938, so a long time ago, but it still comes up. It still comes up today. Obviously that was a large volume of hydrogen in a Zeppelin, and so a significant concentration of hydrogen. Things have changed significantly since then. I mean, we use carbon fiber reinforced polymer pressure vessels. Each of those vessels is CSA certified. They go through tests like bonfire tests. We call it the rifle test, where there's a projectile actually shot at the cylinder, and the cylinder is supposed to basically resist rupturing throughout all of those tests, and all of them are tested to that specification. There have been examples of hydrogen tube trailers. In fact, there are some online on YouTube that have actually caught fire due to a vehicle collision. And one of the things to note about hydrogen, especially when it's in these pressure vessels, is that you can actually, it'll catch fire, it'll make a loud bang, but it can actually be extinguished. I say that because when you think about batteries, which is where we feel the higher risk is in our platform, if they have a short that causes a thermal runaway or some sort of puncture of the cells, which would cause them to ignite, ultimately that fire has to burn itself out before it can, before you can put it out. And so your objective in that case is just to keep the batteries as cool as possible so that, things don't spread. Sorry about that.
Right. No problem. So go ahead.
Yeah, and so just in terms of safety, though, we have the pressure vessels, we monitor the pressure, we have hydrogen leak detectors on board, we have fire eye cameras in case there's a fire, and we have a fairly sophisticated control system that can shut off the hydrogen supply. The fuel cells themselves also monitor flows and pressures into the fuel cell, and they are programmed to shut down if there are any anomalies detected. And so we've done a lot of work, both on board the locomotive with the hydrogen supply system, but also with the vendors to make sure that those scenarios are highlighted so that we can very quickly react to them to avoid an incident. And in all of our testing so far, coupling onto freight cars, moving on the main line, what we call kicking cars or releasing them on their own momentum, the systems have performed flawlessly to date.
That's great. Yeah, I know that in the automotive side, been a lot of discussion about battery fires, car fires due to batteries. But then when you actually look at the number of car fires in a gasoline-powered vehicle, it's actually quite a bit smaller. So I imagine we've kind of got the same. We're used to the dangers of gasoline and diesel, but I guess you won't see hydrogen spilled into a river, or there's just a little bit different risks.
Yeah, absolutely. So, I mean, we use hydrogen gas on board, which ultimately, when it's released into the environment, it's non-toxic. So, unlike diesel fuel, if you had a spill, there would be the associated environmental cleanup. So, hydrogen in itself, at least under a pressurized gas form, is inherently safe, and also safe for the environment, which also gives it an added benefit.
Gotcha. Ultimately, the objective is a carbon-free, kind of a sustainable energy source for freight rail. And so talk a little bit about, a little bit more, I guess, about hydrogen and how it's created, and is hydrogen green, and when is it not green, and how does your program kind of address that, similar to the challenges with battery electric, where the grid might not be renewable. So
yeah, so we thanks to the additional funding we received from the Emissions Reduction Alberta grant, we were able to leverage that to install fueling infrastructure in Calgary and Edmonton to generate our own hydrogen. The facility that we're nearing completion here in Calgary will actually receive its electricity from the Ogden solar farm that we had originally installed to power our head office. And so with water and solar electricity, we can generate green hydrogen to support our testing program. The facility in Edmonton will be hooked up to the Alberta grid. The Alberta grid is actually on a roadmap to decarbonize itself, namely through converting coal-fired power plants to natural gas-fired plants, but adding on carbon capture as well. And so even though we installed an electrolyzer that's being powered by a non-decarbonized grid, over time that grid will decarbonize over time. So, but that's the example for Alberta. Now, when you look at different provinces and states, but specifically provinces in Canada, there are several provinces that already have hydroelectric infrastructure. And so they have the capability of producing electricity and ultimately very low carbon hydrogen. And in fact, what we would call green hydrogen. And so depending on how the program expands, where it expands to, and which province and or state it expands into, the solution for producing hydrogen or for receiving hydrogen supply is going to ultimately depend on that. Alberta, what we're looking to do is take advantage of several initiatives that are looking to productionalize hydrogen, making hydrogen through a process what we call blue hydrogen. So it uses a similar process to steam methane reforming, which they use in the current oil and gas industry to desulfurize diesel fuel. So it's through the refinement process, but they're going to productionalize specific making hydrogen, but then taking the carbon that is the product of that process and capturing it. And so, you know, we really think in Alberta, it's going to be more of a blue hydrogen production location. And so we would, instead of producing our own, we would look to leverage that supply for our terminals within Alberta. So again, it depends. And, you know, there are other incentives in the US, as an example, in the Midwest, that are looking to set up hydrogen hubs and do similar things to what's happening in Alberta.
Gotcha. Maybe the last myth that I want to explore before we get into the Q&A section is the cost of fuel cells. My understanding is that there's platinum that's in the fuel cells. That sounds expensive. But yeah, what are the facts around fuel cells and perhaps how expensive they are relative to either diesel engines or battery or lithium-ion batteries?
Yeah, so if you're looking to modernize a locomotive with fuel cells and batteries, I'd say you're looking at 30% more cost versus modernizing a diesel electric locomotive. And yeah, although it's true that fuel cells do leverage platinum graphite membranes, which are actually fully recyclable or almost fully recyclable, the major challenge with fuel cells, I would say, is the lack of mass production of them. Oh, okay. And so there are concerted efforts by a number of fuel cell vendors to increase automation and production. And I think Ballard had announced probably about a year ago, their CEO, Randy McEwen, mentioned that they are expecting within this decade to reduce the cost of fuel cells by 70%. Having said that, it's all relative. You know, especially in North America and Europe, you're going to see carbon taxes continue to increase post 2030 on fossil fuel-based fuels. And so, you know, you're going to operate post 2030, you're going to look at increasing annual taxes on your fuel. And those increases are going to be significant. In fact, they're going to be creating headwinds within the next 20 years of potentially $800,000 to $900,000 per locomotive in additional taxes on diesel fuel. So, you know, I think what we're going to see is although fuel cells are more expensive now than a diesel engine, as production and adoption continues to increase, those costs are going to drop significantly. Meanwhile, the cost to operate a diesel locomotive are going to increase significantly. And so you're going to see this inflection point. We think it's around 2035, where hydrogen fuel cell locomotives, hydrogen fuel, are going to equalize with the diesel locomotive cost of diesel locomotive operation. And then you're going to see diesel continue to increase, but you're going to see hydrogen continue to decrease after that.
Right. Yeah, we certainly are seeing kind of those tipping points happening in the automotive industry where the initial cost is more expensive for a electric vehicle, but then operating cost is lower, and now the drivetrains are getting less and less expensive as compared to internal combustion. So I guess I mentioned maintenance there, but I think we kind of inferred earlier maintenance cost on a diesel engine versus maintenance cost on a fuel cell, very much different, correct?
They're significantly different, and the fuel cell maintenance is significantly more favorable than the maintenance on a diesel engine. You're going to see the locomotive of the future is going to be a highly electrical locomotive. It has almost no moving parts. Most of the parts on the locomotive are line replaceable, and much of the maintenance that's required are basically as simple as filter changes, air filter changes. And so, yeah, the maintenance costs are dramatically lower. And if my last answer was more about the capital cost of the locomotive, but if you look at the overall life costs of the locomotive, it does become a lot more favorable over time to have a fuel cell electric locomotive.
Gotcha.
The last thing too is if you build it in a certain way, sort of in this sort of kit concept, there are options that you can also leverage to make that maintenance or streamline that maintenance because of the line replaceable nature of the components.
Gotcha. All right. So with that, we're going to switch over to questions. So please, if you have a question for Kyle, yeah, head over to the chat section of the GoToWebinar and fire those questions away. So the first question we have is the production source of CP's hydrogen for its, or what, I guess, what is the source of CP's hydrogen? Is it electrochemical? Are there emissions or combustion byproducts when producing the hydrogen in the use on the locomotives? I guess you addressed that a little bit, but maybe you can expand on it or tie back to your earlier answers.
Yeah, so our main sources are one, the electrolyzers that I talked about. So they would be electrochemical reactions. One being basically powered by our solar farm in Ogden, so very low carbon hydrogen, and the other being produced by the electric grid in Edmonton. So that would be a higher carbon content. The second source of hydrogen is liquefied hydrogen deliveries, and the liquefied source of the hydrogen is from renewable. One source is from renewable energy, so it's green hydrogen. The other source is going to be from Edmonton when the blue hydrogen facility comes online next year, and so it'll be the target will be very low carbon hydrogen.
Gotcha. All right. Early on in my career, I was involved in the conversion from DC locomotives to AC locomotives. And so that new technology brought different policies and procedures when maintaining the locomotive. We had capacitors that needed to be discharged. Are there concerns from the running trades or mechanical employees or their representatives about working with hydrogen fuel cells? And if so, how are you working with those trades to address their concerns?
Yeah, I think that's an excellent question. I mean, there are obviously concerns. I wouldn't necessarily say concerns, more interest than anything. So our mechanical employees and our labor organizations we are engaging with them. Keep in mind, this is still a development program. And as part of that development program, though, we are creating the necessary documentation to perform maintenance on the locomotive, in addition to sort of the various things that you would need in order to maintain the locomotive safely. I think you mentioned discharging capacitors. In terms of our disconnect switches on our batteries, they're all lockout, tagout capable switches. And the other piece I'll say is that 60% of the locomotive platform is the same locomotive platform that they're used to maintaining. So there's a lot of those existing procedures that can be re-leveraged for maintaining the locomotive, and that was done on purpose by design. But ultimately, I think early engagement is critical. And so as the program continues to expand and these locomotives start to find their way into service, then at that point, yeah, the additional training in the shops is going to be critical to ensure safety of our employees.
Right. So as you progress with the program, have you run into any regulatory issues either in Canada or in the US? And then how have you addressed those issues if there have been?
Yeah, so we haven't run into any regulatory issues because these locomotives actually meet all of the current regulations. They aren't net new locomotives. They have the same lights, they have the same event recorders, they, inward facing LVVR cameras, so on and so forth. What we've done is change the propulsion technology. Having said that, realistically, you can't, it's not in our best interest to just say, well, these locomotives meet the current regulations, because the current regulations were designed for diesel electric locomotives. And so our approach really was to engage the regulators early, engage with standards associations early, engage with the AAR early, so that we could start to develop standards and be ready for the ultimate need to introduce regulations into the both Canadian and US and potentially Mexico rail regulatory bodies. And so, yeah, so I think, we're compliant, but we have submitted a significant amount of documentation just to ensure that the regulators are aware of what we're doing and they continue to feel comfortable with what we're doing. And quite frankly, I think it's just good practice around safety.
Right. So next question we have here are there other Class 1 railroads that you're aware of that are working on a similar type of program as CPs?
There are other railroads within North America and the world that are working on, I'd say, similar projects to what we're working on. One of them is located in Canada. It's the Southern Railway of British Columbia, so the SRY. They are working on a 4-axle switch locomotive. There have been historical examples of, like, the Burlington Northern Santa Fe, who also built in, I believe it was 2008, a 4-axle switch locomotive. And the Sierra Nevada Railway has publicly announced that they're building a conversion as well. So we are not the only ones doing this. I would say what makes us unique is that we're actually approaching the 3 different types of locomotives that are operated within North America. So to our knowledge, nobody has done a DC 6-axle line haul locomotive, which we've done. We've done the 4-axle DC switch locomotive, but the last one that we're working on, I think, will be an industry and world first, which is the AC traction locomotive. So keep an eye out for that later this year.
Right. Okay. Next question is on the fuel. So we got hydrogen fuel purity requirements are stringent on the hydrogen fuel. Are there also the same types of requirements on the air side? So is there a particular level of air filtration that's required, I guess, in the air that goes into the fuel cell?
Yeah, actually, surprisingly, no. It's other than some sort of HEPA filters that are put on there. There are no, the requirements of the air are not nearly as stringent as the requirements of the hydrogen.
The hydrogen. Okay. Next question is around kind of I would say, capacity of hydrogen, and so it's around kind of what would you expect from would there be locomotives without tender cars? Would there be tender cars in some situations? Describe kind of what the factors would be, whether all the hydrogen could be stored on the locomotive or a tender is required.
Yeah, it's an excellent question. So it's actually both, just like the question said. So if you're looking at the high horsepower mainline trains, you will require a tender in order to meet the range. Currently, I think, well, I know we currently get 25% of the range of a like for like high horsepower locomotive. So we meet all the horsepower requirements, we meet all the current specifications, but we get about 25% of the range. So having extra onboards, having a tender car with the additional hydrogen will absolutely be required. In a switch operation though, given the fact that you can do direct to locomotive fueling and you can have fixed point fueling infrastructure, it's much easier to decarbonize a terminal and not require the use of a tender. You would require more fueling events than a diesel locomotive, at least in the interim. It wouldn't be as many. You get a bit more range because there's a lot of stop and start in a terminal where you would leverage your batteries as opposed to having your fuel cells online, but you wouldn't get necessarily one-to-one. Having said that, being a Class 1 railway, that's what we do. We build operations around what we have, and so there are plenty of opportunities. Anybody who's sort of switched in a terminal of downtime to be able to sort of make switch locomotives work without having a tender. And then our range testing of our current locomotive throughout Alberta in trains suggests to us that for doing servicing local customers, we would not require a tender to do that. So we could go out on the subdivision, service a grain facility, bring that traffic back into the terminal as an example, and we could do that without requiring the use of a tender.
Right, great. All right, so we got one last question, and I think this is a doozy. So it may be too early to tell, but if the program continues to be successful, could you see CP going 100% hydrogen in 10 years?
Yeah, that's a good question. I think that the technology definitely shows potential. I think there's definitely a lot of excitement at CP and there is a concerted effort from our team and quite a bit of executive support to continue as we deliver results as a team to continue to support the program. If you asked me as an individual, I absolutely want to see this technology be adopted responsibly by CP and other Class 1s within North America. And definitely, as I mentioned, switch locomotives in terminals, local jobs are, in our point of view, a slam dunk in terms of, the technology's there today to have the infrastructure in place. We've demonstrated that you can convert the switcher locomotives actually switching right now here at CP while I'm talking to all of you. Definitely, we don't have a question whether the technology is viable at this point. How fast and how quickly it can adopt, how much capital dollars are going to be made available. There's a lot of focus in Canada and the US around hydrogen blending into utility pipelines with natural gas. We're just starting to get on the radar of off-takers from the government's point of view and from the public's point of view. So I think as that ramps up, absolutely, I think we can make an aggressive plan to do the conversion, but right now there's not a concrete plan necessarily to do that. We need to continue to prove out this technology, get it into the hands of our labor employees 100% of the time, all year round, and then once they sort of get their hands on it, figure out how to support it, and then ultimately that will be the deciding factor. And that is 100% our goal, to make this just as reliable as a diesel locomotive. And that's a big commitment from myself to our leadership and from my team to our leadership.
Right. Well, thank you very much to the attendees today. Great questions, and a huge thanks to Kyle for joining us here today on the LinkedIn Live event. It's been a pleasure. Thank you very much, and everybody be safe. Thank you.